As part of Work Package 9 of the EU-SysFlex project, a demo of a flexibility platform has been developed by ACA, which is interfaced to an aggregator tool, namely the Affordable Tool for Flexibility Services Provider developed by Enoco. The objective of this demo is to study the feasibility of a single marketplace. The development of the flexibility platform has been done in strong collaboration with partners such as Enoco, Ilarion, PSE, Cybernetica, and all other Work Package 9 partners. In this task, a group of IT and business experts have worked together through specification workshops to investigate the business processes, the data exchanges, and the business roles. This video illustrates the functioning of the flexibility platform and its interactions with the affordable tool. The flexibility platform is a single marketplace concept whereby any flexibility buyer, typically TSO and DSO, can meet any flexibility service provider to trade any flexibility product. The flexibility platform is designed to facilitate the coordination of TSOs and DSOs without direct interaction between them, by offering, for example, definition of common flexibility products, joint pre-qualification and procurement of flexibility, coordinated grid impact assessment in order to identify restrictions for flexibility activation, and activation of the same flexibility for both TSO and DSO needs. On the other side, the flexibility platform communicates with aggregators to receive potentials in bids. This could be done through what is called the affordable tool of an aggregator, which is an application enabling smaller customers to actively participate in the energy market through provision of flexibility services and by removing the entry barriers such as setup costs, price, and bid size. Finally, to ensure interoperability of flexibility services, the flexibility platform and the affordable tool address this issue by using the concept of data exchange platform, which provides proper and secure data management. This contributes to the participation of stakeholders across the geographical borders and of any asset. The architecture of the demonstration is composed of several systems: the flexibility platform itself, the affordable tool, and the system operator simulator. There is also SFeed's data exchange platform, which is used to interface all these systems. SFeed provides security mechanisms and standardized data exchanges, for example through REST APIs. The system operator simulators are simple systems which have been built to test the end-to-end processes. For the development of the flexibility platform, open source tools in common development languages or frameworks such as Django, MongoDB, Vue.js, Angular, Python, or JavaScript have been used. In the flexibility platform, the concept of time is crucial. For example, after every gate closure time, the different merit order lists in which bids are grouped and sorted must be calculated. In order to manage this, the Celery framework is used to run the different processes on a regular schedule. It also uses WebSocket technology in order to manage real-time notifications. These technical choices allowed fast and agile developments. Typically, the flexibility platform has been designed as a multi-tier application, separating the front-end, back-end, and storage layers. It results in a system which will be easily scalable. In this demonstration, we have implemented the 4 processes involved in a flexibility service market. These are pre-qualification, bidding, activation, and verification. We started from the processes described in the data system use cases produced in Work Package 5. These system use cases, modeled in UML diagrams and also in SGAM models, have been used as a first level of specification for developments. By implementing a simplified version of them, we have investigated and tested the data exchanges between the stakeholders of the flexibility services market and the feasibility to use a data exchange platform, like SFeed, to support these data exchange in a secure way. Moreover, this development has contributed to identify the data model that is requested to allow an effective functioning of these processes. The first process existing in the flexibility platform is pre-qualification. In this process, a flexibility service provider or an aggregator demonstrates that it complies with all the technical requirements that have been established for the provision of the flexibility product. This process is split in several steps. Before the pre-qualification of a potential, products must be created in the flexibility platform. A flexibility operator could do this manually by filling out a form, for example, to create a MFRR product as shown here. The system operators can also request the creation of products from their information system to the flexibility platform. These creation requests are sent via standardized requests and using the SFeed data exchange platform. The flexibility platform incorporates a protocol for the validation of products. Here is an example showing the launching of the validation process for a product. From their information system, the system operators can also register their future needs for existing products. These are then transmitted to the flexibility platform through standardized APIs. The characteristics of the needs, such as the product, the power, the availability, and the location, are entered, then communicated to the flexibility platform and visible to the FSPs. In the same way, aggregators, from their information system, can declare and submit potentials to the flexibility platform. For example, here in the EU-SysFlex demonstration, an FSP could submit potentials using the affordable tool by filling in characteristics such as the product, the power, the preparation period, and the location. The flexibility platform immediately performs the product pre-qualification by comparing the potential with available flexibility needs. The success of the pre-qualification is reported back to the affordable tool. Aggregators, from their information system, can also declare schedules associated with potentials. Schedules are kind of like baselines. These schedules are sent to the flexibility platform, where they are stored for later use. For each submitted potential, the flexibility platform determines the system operators that should assess the impact of this potential in respect to their networks. Following the feedback from the system operators, the flexibility platform combines the results of the assessment. As such, the grid pre-qualification is performed. The second process implemented is bidding. The flexibility platform handles parallel calls for tender, for which flexibility service providers bid flexibilities for flexibility products, previously defined with system operators and possibly standardized. The flexibility platform organizes the received bids in a merit order list. For the demo, this list is simply sorted on the price of bids, but in a real-life situation, many criteria would be used to optimize the socio-economic value. System operators can initiate calls for tenders for a product offered by the flexibility platform from their information system by completing some information such as the service period, the requested power, and the localization factor. Then, calls for tender are communicated to the flexibility platform with the help of a REST API, and, for example, through the SFeed data exchange platform. Aggregators are informed by the flexibility platform of the calls for tender for which they can submit bids for different products. For example, here, from the Affordable tool, an aggregator submits a bid for an MFRR product specifying the price, power, and location. The flexibility platform receives this bid and executes some validation. For example, it checks that the FSP has a pre-qualified potential related to the submitted bid. After a gate closure time, the flexibility platform selects the bids related to the coming delivery period. For these bids, the flexibility platform determines the concerned system operators and requires an impact assessment in respect to their networks. The system operators provide their response, considering their structural and dynamic constraints to avoid further imbalance or congestion situations. Then the flexibility platform collects and combines the result of the assessments. Displayed here is the result of the grid impact assessment with a power limitation. After this, the merit order list of the bids is established by the flexibility platform, which currently ranks the accepted bids based on price. Of course, this is a simplification of a real-life scenario. As shown here, the merit order list is displayed for the next delivery period with relevant bids, the price of the bids, and the proposed power. The calculation of the merit order list completes the bidding process and the activation process can begin. The activation process is the third process integrated in the flexibility platform. This receives and manages activation requests initiated by the system operators. It is important to note that several activation requests are allowed for the same product in the same delivery period, thus enabling value stacking. Then, the flexibility platform selects bids which can respond to these activation requests. Finally, the flexibility platform prepares and sends the needed activation orders to the FSPs. In return, the FSP sends a confirmation that they have received the activation order. This acknowledgement is registered by the flexibility platform. A system operator can create a flexibility activation request from their information system. For that, they complete different information such as the quantity of power to be delivered for a given delivery period, or the expected localization of the flexibility delivery. Then, the activation request is submitted and recorded in the flexibility platform. We can see here that the activation request has been effectively received by the flexibility platform, which then checks the validity of the activation requests by comparing the activation request's parameters with those of the call for tenders opened by the system operators. Also, we can display the details of the activation request. After the gate closure time and the calculation of the merit order lists, the flexibility platform processes the activation requests by selecting the bids that will satisfy those requests, and then create the corresponding activation orders. What we can see here is this list of activation orders that have just been created by the flexibility platform, and the details of some activation orders. The activation orders are sent to the selected FSPs instructing them to activate the assets. After this, the flexibility platform will receive the confirmation or rejection of the activation orders from the FSPs. In return, the flexibility platform will combine this information to establish an overall status of the activation request. This is what is mentioned here in the field Request Status of this activation request. Here in the Affordable tool, some activation orders have been received from the flexibility platform. They have been automatically activated as shown in the consumption graph. In this graph, you can see all the activated orders. When all activation orders linked to an activation request have been handled by the FSPs, the flexibility platform is informed. The final process developed is the verification of activated flexibilities. This process can start when the metering data are available. The flexibility platform has been designed to be easily interfaced with metering data sources by using data exchange platforms like SFeed. Although, for the purpose of this demo, the metering data have been entered manually. Furthermore, the flexibility platform has integrated in its architecture a big data database to manage the possible huge volume of data, which might be the case when we refer to metering data. When metering data are received by the flexibility platform, the verification can be launched. This is the case here. We can see the notifications that some metering data have been received. Then, it is possible to launch the verification of some activated flexibilities. For example, we launched the verification of flexibilities requested by Ilarin. It means the flexibility platform calculates the difference between the baseline and the actual measurement, and then compares the result with the activation request, in order to identify whether the request was actually activated. The details of the results are displayed here. The verification results are transmitted to the relevant stakeholders. We can observe here that the previously calculated verifications have been received by the concerned system operator. Like a system operator, a FSP can request and receive the verification results from the flexibility platform. In the Affordable tool, it is possible to request the result for every received activation order by clicking on the Request button. The plus sign displayed here means that it has activated more flexibilities than requested. This joint demo, where a flexibility platform, an aggregator tool, and a system operator simulator were interfaced through a data exchange platform, has enabled us to define, investigate, test, and demonstrate the data exchanges between different stakeholders participating in a flexibility market. The results are a data model which could be easily mapped to the CIM model, a flexibility platform which could be turned into a real-life system featuring interoperability, scalability, and replicability, and a tool that provides FSPs with easy and affordable access to the flexibility market. We would like to warmly thank all the EU-SysFlex partners that were involved in this joint demo. Thanks everyone for listening.